Let's start with a question. Have you ever wondered how ChatGPT seems to know what you are going to ask next? Well, that's the magic of LLMs. But what's really happening under the hood? Let's find out together. Shall we? We are about to unlock the mystery behind the technology that powers tools like ChatGPT and Google Gemini. Ever wondered how these AI tools seems to think, answer your question, or even write code? Well, let's break it down together, step by step. In the simplest way, language model, one more time breakdown. Model. First, what exactly is a model? A model is an informative representation of an object, person, or a system. Models can be divided into physical model and abstract model. Physical model, a shape model, a smaller or larger physical representation of an object, person, or a system. Abstract models set a mathematical equation, theoretical representation of a system. Now let's go one step further. What is language model? A language model is a model of the human brain's ability to produce natural language. A language model is a type of abstract model that tries to represent how humans use language, how we speak, write, understand words and sentence. You know, how our brain can guess the next word in sentence or understand meaning, even if the sentence is a bit jumbled. A language model tries to mimic that ability. It's not a physical object. It's actually a set of mathematical rules and patterns, usually inside a computer program, that predict what words comes next, understand sentences, or even generates whole stories, just like human might. How did all this start? Let's step into history for a second. Noam Chomsky did pioneering work on language model in 1950s by developing a theory of formal grammar. Chomsky is generally credited with launching a research tradition of a generative grammar. He came up with a theory called formal grammar. Think of formal grammar as a set of strict rules for building sentences in any language, like the grammar you learn in school, but written a mathematical formula. You remember learning subject plus word plus object, right? That's basic example of a grammar rule. This tradition focused on rules that generates or produce all possible sentences in language, not just understanding what already is there, but imagining what could be said. Ngram models were one of the first tricks. Have you heard the phrase ngram before? It just means looking at a sequence of n words together, like pairs or triplets. Example, a bigram looks at two words at a time. Bi equals to, consider example, I'm happy today. I am happy today. This is a bigram. So how does it work? Ngram models use probability to guess what would come next based on previous words. If good morning appears a lot in your data and you see good, the model will guess morning might be next. They also use a math rule called bias rule to update their guesses based on what they have already said. Now let's go one step further. What is large language model LLM? Large language models are a category of foundation models trained on immense amounts of data, making them capable of understanding and generating natural language and other types of content to perform a wide range of tasks. These are powerful AI models like GPT-4, Gemini, Cloud, or Llama, trained on huge amount of text from books, website articles, and more. Because of this, they can understand language, answer questions, summarize information, translate languages, write stories, and even generate code just like a human might. Example, ChatGPT or Google Gemini. How it works, you type, what's the weather today? Or explain black holes. And the LLM understand how question and gives a human-like response. What's so special about LLMs? LLMs, large language model, are basically our brain behind today's most powerful AI tools like GPT, Google Gemini, Meta IBM's Watson X. They have transformed the way AI understand and generate human language, making AI feel more like talking to a real person than ever before. Why are they suddenly everywhere? LLMs have become super popular because they are at the heart of generative AI. The tech that creates text, code, images, and more. Now, business are using LLMs to automate tasks, answer customer questions, translate languages, and even help write or summarize reports. It didn't happen overnight, although it feels like LLM popped out nowhere. Companies like IBM, Google, Microsoft have spent years developing them. They are built on top of advanced machine learning, neural networks, and transformer architecture. The magic that lets the uns understand context, generate coherent responses, and learn from massive amount of data. Why not just train a small data models? In the past, companies would build small AI models, each specific job, one for translation, one for chatbot, one for summarization, etc. But LLMs are trained on huge varied datasets. So a single model can do it all, write, translate, summarize, answer, question, and more, making them much more efficient and powerful. What can LLMs actually do? Understand context in conversation so they respond like a real person, translate between language instantly, summarize long documents in seconds, generate code or creative writing, answer FAQs and general knowledge questions, power chatbots, virtual assistants that help in customer support, research, and more. Why do LLMs work so well? They use billions of parameters. These are like settings that help them notice subtle pattern in language. Because they are trained on so much data, they get really good at predicting what comes next in a sentence, generating realistic content, understanding complex instructions. In short, LLMs are foundation of model AI that makes technology smarter and more human-like. As they keep improving, they will change the way we interact with information, work, and even create content. So, key takeaway: LLMs are just a tech trend. They are engine driving the next generation AI tools in every industry, making our interaction with technology smoother, faster, and more natural. Why do we train LLMs on billions of words? Ask yourself. If you wanted to get really good at English, wouldn't you read as much as possible? That's exactly what LLMs do. They read billions of web pages, books, and articles to learn the pattern of language. Isn't it fascinating how they use all that data just to understand what you might want next? What's so special about this transformer thing? Have you heard about transformers? No, not the robots in AI. Transformers are a type of neural network that's really good at understanding context. Let's say you read the sentence. The bass was so loud, the fish jumped out of the water. Which bass? Do you think that is music or a fish? LLMs use something called attention. They focus on all the words to figure out the right meaning. Pretty clever, isn't it? But how does AI read words? Here is a question. Can a computer actually read like us? No. It needs to convert everything into numbers first. That's called tokenization. So if I I give it the words cat, it turns it into numbers the model understand. Ever thought about how that might help with different language too? So how does an LLM learn to predict the next word? Imagine you are playing a guessing game. If I say once upon a, fill in the blanks. What comes next? Time, right? That's what LLMs do. Predict what comes next based on what they have seen before. And the more example they see, the better they get. Don't you agree? Why should we care about tuning and feedback? Have you noticed that sometimes AI can give weird or even wrong answers? What do you think we can do about that? Right. We give it feedback. Engineers use tricks like prompt engineering and fine tuning to make the models safer, smarter, and less likely to make mistakes. Wouldn't you want your AI to be as helpful and safe as possible? So let's recap what we have learned. LLMs learn by reading huge amount of text. They use transformer and attention to figure out meaning. Tokenization turns words into numbers. They get better with practice and feedback. Sounds a lot like how we learn, doesn't it? Thank you.